Good day, viewers. This is the ABC. On the board we have mathematics, and the topic is multiplication of matrices. Remember that we've done multiplication of scalar before. This is the non-scalar multiplication. And then there is a condition you have to have in mind, or there is a condition that must be established for two matrices to be multiplied. And that condition is that the number of columns of the first matrix, that is NC of 1, must be equal to the number of rows of the second matrix. This one represents the first matrix, and this 2 represents the second matrix. C represents column, and R represents row. Another way of writing this is by saying that CR7. This is the condition. Of course, you know who CR7 is. Alright, so if you forget the rule of the conformability, you can quickly remember this. Meaning that the number of columns of the first matrix must be equal to the number of rows of the second matrix, and it goes this way. Meaning that if you have a matrix, okay, you have A, B, C, D, and it is multiplying, let us say M, N, P, and then Q. Okay, we have this. For this to be multiplied, this is, remember that this is column. This is column. If you count it, it is 2 in number. This is row. This is row. If you count it, it is 2 in number. So the number of column, the number of this column, it is 2, must be equal to the number of row. This is row of the second matrix. This is column of the first matrix. This is row of the second matrix. So this number must tally with this number, and it is going this way. That is why it is called CR7. So if this rule or if this condition is established, that means you can multiply two matrices. Let us try it out. Okay. So we are given a matrix A equal to, of course, you know the type of matrix that this is. We define it in our definition of matrices. And then, of course, it's a row matrix and this is a column matrix. So we are going to find our AB. So we start by saying that AB, that is A times the matrix B, matrix A multiply matrix B, is going to give us 3, 4 times 1, 2. Alright. It is a matrix and equally a vector. Okay, so how do you multiply this? Okay, we say that this is going to multiply this, and this is going to multiply this. First of all, they are conformable because this, the column here, row here, they are conformable, and it is going this way. Once you count the elements that is horizontal in the first one, and it is equal to the number of elements in the vertical of the second one, then you can multiply them. So we now have our AB to be 3 will multiply 1. So we have 3 times 1. Okay, so now we have plus. 4 is going to multiply 2. So we have 4 times 2. 3 times 1 is going to give us 3, of course. So we now have 3 plus. 4 times 2 is going to give us 8. And 3 plus 8 is equal to 11. So if you watch, you are going to observe that this number we are seeing here is a scalar. Meaning that if you multiply a vector with a vector, and those vectors, their multiplication, or they are conformable over multiplication, then definitely you are going to get a scalar quantity. Alright. Okay, let us evaluate our BA. Our BA, if you watch our BA, it is written this way. Well, if you quickly look at this is arranged in a way that this A is going to multiply this, and this is going to multiply this. Meaning that the item here, this A multiply them and B multiply P, and you are going to add them together. But this matrix is not in that form. Hence, we conclude that our BA is not conformable. So there is no answer to this. Let us look at example 2. Our B is equal to this, and our Q is equal to this also. How do we evaluate our DQ? We are going to try that out in our next video. Thank you, and God bless you.